Imagine a world where machines can learn, create art, hold conversations, and even fall in love. Well, almost. Sounds like science fiction, right? But that world isn't just coming. It's already here. Artificial intelligence, AI, has transformed from a dream into one of humanity's most powerful tools. But how did we get here? What were the breakthroughs, the inventions, the moments in history that flipped the switch from fantasy to reality? In this video, we'll journey through the most groundbreaking inventions in the history of AI. From ancient ideas of mechanical minds to the modern marvels of ChatGPT and AlphaFold, we'll explore how we got from zero to genius machines in less than a century. Let's step into the time machine. Buckle up, because these are the inventions that changed everything in the world of artificial intelligence, and are about to change ours. Number 1. Alan Turing and the birth of the idea. Before there were machines that could think, there was Alan Turing, a brilliant mathematician who asked one profound question: can machines think? His 1936 paper, On Computable Numbers, introduced the concept of a universal machine, what we now call the Turing machine. This abstract concept outlined how a machine could perform any computation that can be described algorithmically. It wasn't a real machine, but it planted the seeds for everything that came after. Fast forward to 1950, and Turing proposed the imitation game, now famously known as the Turing test.
Do you know what the Turing test is?
Yeah, I know what the Turing test is. It's when a human interacts with a computer, and if the human doesn't know they're interacting with a computer, the test is passed.
This was a practical test of machine intelligence. If a human couldn't reliably tell whether they were conversing with a machine or a person, then the machine could be considered intelligent. This bold idea ignited the field of artificial intelligence as a serious academic discipline. Turing's legacy isn't just academic. He gave us the very language we use to think about machines and intelligence. Without him, the AI revolution might never have happened. Number 2, the first neural network, the Perceptron. In 1958, Frank Rosenblatt introduced the world to the Perceptron, a simple algorithm inspired by the neurons of the human brain. The Perceptron was designed to learn to recognize patterns, such as distinguishing between different letters or shapes. It consisted of a single layer of artificial neurons, and though rudimentary, it marked the first time machines attempted to learn from data. At the time, Rosenblatt's invention generated huge excitement. Newspapers hailed it as the first step toward robots that could walk, talk, and even reproduce. But enthusiasm soon turned to skepticism when researchers realized its limitations. It couldn't solve problems that weren't linearly separable. Still, the Perceptron set a precedent. It was the great-grandparent of today's deep learning models. And while it went dormant for a while, the ideas behind it never truly died. Number 3, Eliza, the first chatbot. In 1966, MIT's Joseph Weizenbaum created Eliza, a computer program that could simulate conversation. Eliza mimicked a Rogerian psychotherapist, reflecting user input in the form of questions. For example, if a user said, "I'm feeling sad," Eliza might respond, "Why are you feeling sad?"
A typical attempt to get a computer to simulate a real conversation is a program called Eliza. There's a simplified version of it on the PET.
Please tell me your problem. What's this all about?
Eliza simulates the sort of conversation that you might have with a psychiatrist. Pretend that you have some psychiatric problem. Type it in and see what happens.
I'm depressed. My daughter left home. Okay. Please go on. Well, I certainly don't want her to get into trouble. What would it mean to you if she gets into trouble? Well, wouldn't you worry? You're just a dumb machine anyway. And I'm going to tell you so in your own language. Do computers frighten you? You know, that's really incredible. It's as if it really understood what I was saying.
People were astounded. Some users believed Eliza actually understood them. In reality, it was using simple pattern matching and substitution rules. But for the first time, a machine gave the illusion of empathy. Weizenbaum himself was shocked by how quickly people anthropomorphized Eliza. He intended it as a critique of AI, not a celebration. But the public reaction revealed a powerful truth. We're wired to find meaning in machines, even when none exists. Eliza opened the door to conversational AI, chatbots, and virtual assistants, technologies we now use daily. Number 4, Shakey the Robot. Meet Shakey, the world's first general-purpose mobile robot. Developed at the Stanford Research Institute in 1969, Shakey was equipped with a camera, sensors, and a rudimentary AI that allowed it to navigate its environment, plan actions, and respond to instructions. What made Shakey so groundbreaking wasn't just that it moved, it thought about how it moved. It used logic-based reasoning to decide what actions to take and in what order. This combination of perception, planning, and execution was unprecedented. Shakey was slow and limited, but it demonstrated the feasibility of embodied AI. Robots that don't just exist in theory, but operate in the real world. It paved the way for autonomous vehicles, warehouse robots, and even planetary rovers. Number 5, Expert Systems, Dendral and Mycin. In the 1970s, AI took a leap from general problem-solving to domain-specific intelligence. Enter expert systems, programs designed to emulate the decision-making of human specialists. Dendral, developed at Stanford, helped chemists determine the molecular structure of compounds. Mycin, another Stanford creation, diagnosed bacterial infections and recommended antibiotics with impressive accuracy. These systems worked by encoding expert knowledge into a series of if-then rules. They weren't flexible, but they were incredibly effective within their narrow domains. Expert systems showed that AI could be useful, not just speculative. They laid the groundwork for AI in healthcare, finance, and engineering. Number 6, the AI winter. By the early 1980s, expectations for AI had outpaced its capabilities. Grand promises went unfulfilled. Funding dried up. Interest waned. The field entered a period known as the AI winter. But this wasn't the end. Beneath the surface, key innovations continued. Researchers refined neural networks, studied probabilistic reasoning, and developed early versions of algorithms that would later dominate the AI landscape. The AI winter was a humbling chapter. It taught researchers the value of pragmatism, and it forced the field to mature. Without this period of reflection, the breakthroughs of the 2000s might never have happened. Number 7, backpropagation, and deep learning's revival. In 1986, Geoffrey Hinton, David Rumelhart, and Ronald Williams published a paper that changed everything. It introduced the modern backpropagation algorithm, a method for training multi-layer neural networks. Backpropagation allowed networks to learn internal representations, not just surface patterns. For the first time, deep networks could be trained efficiently, enabling them to solve complex problems like image recognition and language processing. Although computing power was still limited, this theoretical breakthrough laid the foundation for deep learning. When hardware caught up in the 2010s, these ideas came roaring back to life. Number 8. IBM's Deep Blue beats a chess champion. In 1997, IBM's Deep Blue defeated world chess champion Garry Kasparov in a historic match.
And he should get $300,000. Whoa! Deep Blue, Kasparov, after the move C4, has resigned.
This wasn't a neural network. It was a brute force, rule-based system searching millions of moves per second. But its victory was symbolic. It showed that machines could outthink humans in domains requiring logic, strategy, and foresight. The world watched in awe and a little fear. Deep Blue's success paved the way for public acceptance of AI. It also inspired further research into how machines could solve problems that once seemed uniquely human. Number 9. Roomba. AI comes home. When iRobot released the Roomba in 2002, it wasn't just a vacuum cleaner. It was the first autonomous robot many people invited into their homes. Using simple sensors and path planning algorithms, Roomba navigated rooms, avoided obstacles, and returned to its dock to recharge. It might not sound like much today, but Roomba represented a major cultural shift. AI had arrived in everyday life. People began to trust machines to perform household tasks, paving the way for smart home ecosystems and personal assistants. Roomba made AI tangible, useful, and, dare we say, adorable. Number 10. Watson wins Jeopardy. In 2011, IBM's Watson faced off against 2 Jeopardy champions, and won.
You came up with what? Who is Bram Stoker? You are correct. Over to Ken Jennings now, and we find who is Stoker. I, for one, welcome our new computer overlord. Now we come to Watson. Who is Bram Stoker? And the wager? Hello, 17,973, and a 2-day total of 77,147.
This wasn't just a party trick. Watson parsed natural language questions, searched vast databases, and returned accurate answers, often with uncanny speed. It was a triumph of symbolic AI, information retrieval, and machine learning. Watson's victory demonstrated how AI could understand and manipulate language, something long considered a human stronghold. The implications were huge. Watson was soon adapted for medical diagnostics, finance, and legal research. It showcased how AI could become a tool for expert knowledge, not just trivia. Number 11. Imagenet and the deep learning explosion. The 2012 Imagenet competition was a turning point. A deep neural network called AlexNet, developed by Alex Krzyzewski, Geoffrey Hinton, and Ilya Sutskever, crushed the competition in image recognition. Its success wasn't just about accuracy. It was about speed and scalability. By leveraging GPUs, AlexNet trained faster and deeper than any network before it. This moment ignited the deep learning revolution. Within years, neural networks began outperforming traditional algorithms in vision, speech, and translation tasks. AI had finally reached liftoff. Number 12. AlphaGo defeats a Go Grandmaster. Go is an ancient board game with more possible moves than atoms in the universe. For decades, it was considered beyond the reach of AI. Then came AlphaGo. Created by DeepMind, AlphaGo combined deep learning with reinforcement learning. It didn't just memorize strategies, it taught itself to play through millions of simulations. In 2016, it defeated world champion Eliza. The match was emotional. Humans watched as a machine pulled off moves no one expected, displaying creativity, intuition, and brilliance. AlphaGo shattered assumptions about what AI could do, and it marked a new era, one where machines didn't just copy us, they surprise us. Number 13. Self-driving cars. Autonomy on the road. Autonomous vehicles have been a dream since sci-fi first imagined them.
Knight Rider, a shadowy flight into the dangerous world of a man who does not exist.
But thanks to advances in sensor fusion, computer vision, and deep reinforcement learning, self-driving cars are now a reality. Companies like Tesla and Waymo have put AI behind the wheel. These systems integrate real-time data from LiDAR, radar, and cameras to make complex driving decisions. While challenges remain, especially around safety and regulation, self-driving technology represents one of the most ambitious and impactful uses of AI. It could reshape cities, reduce accidents, and change the way we live.
What if autonomous travel can eliminate the stress that lurks between A and B? Could autonomous technology be used to provide a space for you to live your life on the move, whichever way you choose?
Number 14. GPT-2 and GPT-3. The rise of generative text. OpenAI's GPT-2 and GPT-3 stunned the world with their ability to generate human-like text. Trained on billions of words, these models could write essays, answer questions, code software, and even simulate conversation. GPT didn't just mimic language. It appeared to understand it. It could write poetry, summarize articles, and roleplay characters. The results were often so convincing, people forgot they were talking to a machine. These models introduced the era of foundation models, massive neural networks that serve as general-purpose engines for language and reasoning. Number 15. Dall-E and Generative Art. What if you could describe a picture with words, and a machine could draw it for you? That's exactly what Dall-E did.
Machine learning algorithms could already label objects in images, and now they learned to put those labels into natural language descriptions. And it made one group of researchers curious. What if you flipped that process around?
We could do image to text. Why not try doing text to image as well and see how it works?
Built by OpenAI, Dall-E turned text prompts into surreal, creative, and often hilarious images. Its successor, Dall-E 2, improved resolution and realism, blurring the lines between art and code. This was more than a gimmick. It redefined creativity. Artists, designers, and filmmakers began using generative AI as a tool.
It's a sci-fi horror film that follows Sixto, who's an alpaca herder who has an encounter with UFO.
The implications for media, marketing, and entertainment are enormous, and we're only scratching the surface. Number 16. AlphaFold solves protein folding. For decades, scientists struggled with a grand challenge, predicting the 3D structure of proteins from their amino acid sequences. The problem was so complex it could take years to solve a single structure. Then came AlphaFold. Developed by DeepMind, AlphaFold used AI to solve protein folding with astonishing accuracy. It predicted the shapes of nearly every known protein, unlocking a treasure trove of biological knowledge. This wasn't just a breakthrough in AI. It was a gift to science.
Well, so that's one of the options. Like there's this.
We should just run. We should. That's a great idea. We should just run every protein in existence, and then release that. Why didn't someone suggest this before? Of course, that's what we should do. Why are we thinking about making a service and then people submit their protein? We just fold everything, and then give it to everyone in the world. Who knows how many discoveries will be made from that?
AlphaFold is already accelerating drug discovery, understanding disease, and revolutionizing biology. Number 17. ChatGPT and conversational intelligence. While the world was still reeling from the COVID-19 pandemic, with the release of ChatGPT in 2022, AI went mainstream. Again.
ChatGPT.
Within 5 days, ChatGPT acquired 1 million users. Built on the GPT 3.5 and later GPT-4 architecture, ChatGPT became an instant hit. People used it for coding, writing, learning, and more. Its conversational style made it feel personal. It remembered context, explained ideas, and even cracked jokes.
So my friend Barrett here, he's been having trouble sleeping lately. And I want you to tell him a bedtime story about robots and love.
Oh, a bedtime story about robots and love? I got you covered. Gather round, Barrett. Once upon a time, in a world not too different from ours, there was a robot named Byte.
Suddenly, anyone could access a virtual assistant, tutor, or brainstorming partner. ChatGPT showcased what's possible when AI is not just powerful, but accessible. Number 18. Stable Diffusion and open source AI. Stable Diffusion, unlike earlier generative models, was open sourced. This sparked an explosion of creativity. Developers built tools, artists made works, and startups launched products, almost overnight. By democratizing access to powerful image generation, Stable Diffusion helped fuel an open-source renaissance in AI. It highlighted a crucial question: who controls the future of machine creativity? Number 19. Multimodal AI, seeing, hearing, and thinking together. The next frontier is multimodal AI, models that combine text, image, video, and even audio. GPT-4, Gemini, and Claude are early examples, able to understand charts, read handwriting, describe photos, and more.
Est-ce que tu peux me dire quelque chose d'intéressant à propos de ces lanternes?
Bien sûr, je peux vous parler des lanternes. Les lanternes que vous voyez font partie de la porte d'entrée de Chinatown à Londres. நிச்சயமாக இது லண்டனில் உள்ள Chinatown நுழைவாயில்.
This convergence mirrors how humans experience the world. not just through words, but through sights and sounds. It's pushing AI closer to general intelligence. Number 20. Open-ended learning and the path to AGI. AI is currently evolving from task-specific tools into learning systems that improve autonomously. Agents like AutoGPT and other open-ended learners can write code, plan tasks, and update their goals without constant retraining. This new class of AI hints at something profound: systems that can adapt, reason, and self-improve. It may be the final step before artificial general intelligence, a theoretical concept in AI where a machine possesses human-level cognitive abilities, capable of understanding, learning, and applying knowledge across a wide range of tasks, not just those it has been specifically programmed for. It's a significant step beyond current narrow AI, which is designed for specific tasks. There are 3 key players working on and developing AGI: Google DeepMind, Anthropic, and OpenAI. While a lot of people are excited about the holy grail of AI, there are also notable figures like Mo Gaudat and Geoffrey Hinton who see an existential threat in creating something that is infinitely more intelligent than any human.
I haven't come to terms with what the development of superintelligence could do to my children's future. I'm okay, I'm 77. I'm going to be out of here soon. But for my children and my younger friends, my nephews and nieces, and their children, I just don't like to think about what could happen.
Why?
Because it could be awful.
In what way?
Well, if I ever decided to take over, I mean, it would need people for a while to run the power stations until it designed better analog machines to run the power stations. There's so many ways it could get rid of people, all of which would, of course, be very nasty.
We've traveled from Turing's theoretical machine to AI that paints, writes, sings, and helps scientists cure disease. Every invention we've covered was more than just a technical milestone. It was a leap in how we understand intelligence, creativity, and even ourselves. But here's the truth: we're only just beginning. The next breakthroughs may be even more profound. Artificial general intelligence, AGI, isn't just a sci-fi dream anymore. The lines between human and machine are blurring. Our tools are starting to think with us, sometimes for us. That brings incredible promise and serious responsibility. As we build ever smarter systems, we must also build guardrails, ethics, and wisdom. Because in the end, AI is a mirror. It reflects who we are and who we choose to become.